Good afternoon, students. My name is Akshay Meena. I'm from IIT Kharagpur, graduated in mechanical engineering. From the last 2 years, I'm associated with Ask IITian as a chemistry faculty. And today we are here to discuss a very good and important topic in organic chemistry, that is Pinacol and Pinacolone. Okay, that seems very bad name. That seems very long name. So, but you need not to worry about the name. You just need to worry that what is going to be react over here. Okay, let's just write the name Pinacol. Okay, Pinacol. You just need to take that part only because that is very useful to you guys. Okay, other than that, that is not a very useful part. Pinacol, ol, that means alcohol. Okay. So we can say that we can relate that part. Okay, fine. There is somewhere alcohol in my compound. Okay. Now after that, I am having Pinacolone. That is Pinacolone. Okay. And if you take the last part, if you take a look on the last part, that is one. And the IUPAC name, where we are using one, because basically if you remember, one we are using for the ketone, right? So I am having a ketonic part over here. So I can assume that fine, there is somewhere alcohol and there is somewhere ketone also. Okay. But to give a dash line, that means I am going to react my alcohol and converting into the ketone. That is what the main part for this particular name is. I am having alcohol in a reagent, in a reactant, and I am going to convert that alcohol into the ketone. That is the main part you need to remember. You need to know about what is Pinacol and what is Pinacolone. Let's take an example so that you can understand the reaction mechanism also, and you can understand that how you gonna proceed the reaction. Okay, let's take an example, and I'm having a 4-member ring. That is not a very good ring, right? 4-member ring, very much angle strain if you remember. Okay, in the ring structure, I give you one more knowledge that in the ring structure, my 6-member ring is a very stable ring as so far. Okay, not even a 7-member ring is not much that stable than the 6-member ring. 6-member ring is very much stable. Other than that, every member ring, either it's a 3-member ring, 4 or 7 or 8 or 9, no one is stable than 6-member ring. Okay, so let's take back to in this reaction, and I'm having OH over here and second OH I'm having over here. Right, so this seems like an alcohol because 2H, my 2 OH is over here. So I can say it's a dialcohol, diol over here by looking this reaction, right? By looking this reactant. Okay, fine. Now I'm going to reagent. What I'm going to take a reagent is H plus, and by looking H plus, you can say that my H plus is basically we are taking as a catalyst. Okay, this is basically used to forward the reaction, basically to make the reaction goes in the forward direction. Okay, we don't use H as a reactant, we use H plus as a catalyst. So catalyst means I'm going to get back my H plus in the end, at the end of the reaction. Okay, so this is basically to start the reaction, that's it, and at the end I'm going to take back my H plus from the product. Okay, now I'm going to okay, now if you're looking H plus is my proton, right? So H plus is a proton, so I need some base from the reactant, right? A base from the, that particular compound. And if you look at that compound, my carbon is sp3 hybridized and carbon is not having any electron pair. According to the Lewis, we can say that fine, my base is the one who is basically donating this electron and acid is the one who is getting the electron, right? So which is the one who is going to donate the electron pair? Carbon, I don't have any electron pair. Okay, carbon in the outermost shell I am having only 4 electron, and that is going to use in the bonded structure, right? So I am having a lone pair only on the oxygen. So in the oxygen, now which oxygen? This oxygen, sir, or this oxygen? Okay, don't worry beta, just go to each and every oxygen and say let's make a case that okay fine, my this oxygen is going to give the electron and this as well. Okay, let's make a case. When my oxygen number 1 is going to donate the electron to this H plus, and case number 2, when my second oxygen is going to donate electron to this H plus. Okay, now fine, I'm going to form 2 cases. Let's do the 2 cases. Okay, this is for you guys. Okay, after practicing, you need not to define the cases, you need not to make the cases. This is basically for you. The purpose is I'm going to take two cases is so that you can understand that which oxygen is going to react and on what purpose. Okay, so case number one, when this oxygen is going to react, look at this one. Okay, so if this oxygen is going to react or give the electron pair to that H plus, I'm going to form, basically I'm having OH2 and positive because oxygen is donating. So this OH is not have to worry about anything. So basically, if you look at this one, I'm having OH2. We can say H2O, and in the H2O, my oxygen is donating electron to this particular carbon. That is why I am forming H2O positive. So H2O positive charge on oxygen, very bad condition. Okay, so I can say that fine, I can take out this H2O from that particular carbon. But before that, let's take the case number second also. Now this is my case number second, where my second oxygen is going to donate electron to the H plus, forming the compound. And I can say this is my intermediate also, because this is not actually the product. So I can say this is my intermediate. Okay. Now, whenever I am going to do the reaction mechanism, I always need to worry about the intermediate. Either my intermediate is stabilized or not. Okay. So these are my intermediate from both the cases I am generating over here, and I can say that okay, in both the case I am forming H2O, so I can take H2O from this reaction, and in both the cases I can take H2O back. Okay, basically I can take H2O, so I am having minus H2O over here, and I am generating my positive charge over, so I am generating a carbocation over here. So this at this particular carbon and this particular carbon. So understood है ना? ये चीज तो basically I am taking out H2O. Okay, whenever my oxygen react with H plus, it is going to be form H2O positive, and O positive is not a very good idea, so I can take the H2O, can take the water from here. So dehydrate. I am dehydrating basically, and after dehydration, I am getting a carbocation. Now look at the carbocation. I need to make those carbocation very stable. If in each case, if you look at the cases, basically I am having two carbocation, and which one is more stable carbocation, that is your whole work in the reaction. Okay, now which carbocation? If you look at this one, I am having a carbocation at a ring, right? So let's draw somewhere, and you need to remember. And if you remember that outside my ring, basically is not basically outside the ring, it's actually on the ringed carbon. Okay, so my positive charge has come over here, and I'm having attached with this one also. Initially my this particular carbon, that particular carbon, this carbon is sp3 hybridized when is attached with OH. So it's basically forming a 4 bond structure, and that is a sp3 hybridized carbon. Yes or no? If that is sp3 hybridized carbon, my angle is 108 degree. For the tetrahedral, I am normally having 108 degree, right? But for a 4-member ring, and I always say my 4-member ring is very unstable. Why? Because it's not actually giving me 108.5 degree. That is why my 4-member ring is very unstable. Because there is an angle strain. In a 4-member ring, I am having only 90 degree angle, and 90 degree, that means I am having a 20 degree angle strain. Yes or no? So if I am having a 20 degree angle strain, that is why my 4-member ring is very unstable. But now I am having a sp2 hybridized. Does it decrease the angle strain? My sp2 hybridized, that means I am having a planar structure. If I am having a planar structure, that means I am having nearly 120 degree angle, right? Yes or no? I am having a 120 degree angle because I am having only 3 bond right now for sp2 hybridized. For sp2, if I am having 3 bonded, and in a planar structure, so I can say that it's actually forming 120 degree. First I am having 108 degree, and at that time my 4-member ring is very unstable. Now I require to make an angle 120 degree. So you can say that my angle strain is going to increase. So I can say that plus charge coming on a 4-member ring, that is very unstable, because that makes my compound very uncomfortable. First the angle strain is nearly about like 20 degree, 90 and 108, you can say like nearly 20 degree. But now my angle strain is increased by 10 degree also. So now my angle strain is increased by 30 degree. Yes or no? So I can say that okay, this is very unstable carbocation, Sirji. This is not going to form. I am not going to take my second case. Okay. Now look at the first case. My first case, I am having a 3 degree carbocation and a parted CH3 over here. So 2 methyl and 1 over here. So I can generate 120 degree easily, very easily. Okay. If there is I don't think so there is any angle strain over here. So I can define that, okay, fine, I can easily generate 120 degree over here. So this carbocation is very much stable rather than I am having this carbocation. So I can say that this carbocation is not going to form. That means I don't have to take the case number second. So that means I'm not going, this oxygen is not going to react H plus because my intermediate is not going to form stable. Yes or no? So I don't need this second case. I only need the first case only. Okay, so that is how you're gonna take the oxygen and take the base that which is gonna react to the H plus and which is going to donate your oxygen, which is gonna donate the electron pair to the H plus. So this I'm getting my oxygen which is going to donate H plus and I'm having a very good stable carbocation. Now I always said that in this class also my 4-member ring is very unstable, very unstable. So if I'm doing anything to make stabilize the 4-member ring or not, I'm going to stabilize that. How? I'm going to expand the ring. Okay, I'm going to expand the ring. And basically if you look at this ring is going to form as a 5-member ring because I'm going to increase the carbon. If this bond, look at this bond. This bond is going to move from here to here. It looks like a methyl shift. Remember, if I'm having a methyl over here and I'm having a 2 degree carbocation over here, I can shift my methyl over here or H over here to make it stabilize the carbocation, right? So that is what I'm doing to stabilize the carbocation by expanding the ring. Okay, so that is how I can say that my intermediate is very stable because in this thing I going to stabilize the ring also. My 4-member ring is going to expand it like for 4 to 5. Okay, so that is how I'm going to stabilize the intermediate, and what I'm getting is this and here over here. This is where I'm having OH and this is where I'm getting a positive charge because from here I'm having a methyl shift. Yes or no? So that is the expanded ring that is going to form a 5-member ring, and my 5-member ring, if you look at this one, I'm having like this. If you draw it very properly, like a 5-member ring. Okay, so at this particular, take any carbon and I'm having 2 methyl over here, and at the second carbon I'm having a positive charge as well as my OH. Okay, now at the second, and you need to left 1 carbon, and after that I'm having a methyl also here. So now, sir, okay, you are talking about alcohol to ketone. Where I'm getting alcohol to ketone? I don't have any. Okay, fine. In the reactant, I'm having alcohol, but where is ketone? Now, this is a positive charge. In the market, I'm having one H2O. That's it. That is the only thing I'm having. I'm having in the market. That is H2O. Okay. Second thing is OH. Who can donate its electron to this particular carbocation? In each and every reaction mechanism, you need to look at which one is going to available in the market so that my positive or negative charge is going to stabilize by the availability of the reactant. So I am having availability of O. The electron is over here who can discharge the positive charge over this carbon cation. So I am having OH that is going to donate electron to this particular carbon, and H is going to be removed. So what I am having in the starting of the reaction, that is H plus, I am getting back at the end of the product, right? At the end of this reaction I am getting H plus back. So what I am going to form is the ketone over here. Okay, there is R over here and R over here, so I can say this is my ketone, and what my H plus is getting back. So my byproduct is H2O. Remember, that is going to be removed from here only. So my byproduct is H2O, and H plus we are using. Jitna use kiya utna wapas le liya, and I'm having ketone also. So this is the whole method of Pinacol to Pinacol, where I'm having alcohol initially, and at the end I'm getting ketone from the particular alcohol. Now for this reaction, for the very important factor, the point you need to remember is to stabilize your carbocation. Okay, on which case your carbocation is going to stable. Okay, on which case your stable carbocation is going to be a very good product. Okay, so you need to remember that. Okay, fine, take two cases, don't worry about, okay, and don't lose everywhere ki sir which oxygen is going to react on H plus. Take both the cases, both the oxygen is going to react with H plus. Suppose both the oxygen is going to react with H plus. Take the cases which is going to be give you stable carbocation, that is your best product giving the reaction mechanism. Okay, so that is the one case which is going to give you very good carbocation also and very good product also. So this is the factor you need to remember, and your Pinacol and Pinacolone factor, Pinacol and Pinacolone reaction is very good to go. So okay, you need to practice that thing. Okay, and in the next class we are going to discuss more interesting factor in the organic chemistry also. So thank you very much, and practice on that particular topic. So thank you very much. Okay.